Today we are doing test corrections for Chapter 3. Alright, test corrections for Chapter 3. Hopefully you have signed your name and put the date so that you get credit for that one. One quick pro tip, never put, for this year, never put just 20 right there, because someone can go in there and they can fill out something that's wrong if it's some kind of important document. Alright, that's just a life lesson. Alright, here we go. Determine whether the relation is a function. If the relation is a function, determine whether the function is linear or nonlinear. So, let's see if it's a function. From 1 to 3, we add 2. 3 to 5, we add 2. 5 to 3, we subtract 2. Uh-oh. Not looking linear, but oh look, there's a 3, 2, 3, negative 2. You can't have two different outputs for one, so this is not a function. Let's look over here. We have a y equals 2x plus 3. So this is written in slope-intercept form. This is a line if this exponent and this exponent are 1, which they are. So this is a function, and it's linear. Let's go down here, y equals 3. Well, we see we only have one exponent, so it's a function. And this y equals 3 is linear. If we were to graph it out, 1, 2, 3. Y equals 3 every time, you get a line that looks like this. Y equals 7 plus 5x squared. Oh, we look right there. This is not a function. Oh wait, no, I'm sorry. It's not a line, excuse me. It's not a line, but it is a function. Now let's look at the 3 of these in Desmos calculator. Well, this one we don't have to look at because it's not a function. We have two different outputs for the same input. But let's look at y equals 2x plus 3. Y equals 2x plus 3. Yep, it's a line, and it passes the vertical line test. Let's check out y equals 3. Y equals 3 looks like this. It's this black line right here. That passes. And then we have y equals 7 plus 5x squared. Y equals 7 plus 5x squared. It's right there. So, okay. Carrying on. Remember, pause this whenever you need to do your corrections. You don't need to do every single one. If you got it correct and you're showing your work, then you don't need to redo it. But definitely if you got it wrong, redo it. And if you didn't show your work, make sure you show your work. Find the domain and range of the function represented by the graph. Determine whether the domain is discrete or continuous. So the domain, that's all our x values. So this goes on infinitely, both directions. So that means it covers all real numbers. So our x value is all real numbers. And then what about our y value? Our y is our up and down. It looks like there's no value less than 0 on our y line. So y is greater than or equal to 0. And then is it discrete or continuous? Well, it continues, so it's continuous. Versus this one, let's check it out. What's our domain? Well, the easiest way for me to do domain and range, to do my x values and my y values, when it's discrete, because it's a series of points. It's not continuous, it's discrete. The easiest way for me to do it is to write out each point. So this point is negative 2, negative 1. This point is negative 1, negative 1, 3. This point is 0, negative 2. And this point is 1, 2, 3, 0. So my domain are all my x values. So I have negative 2, negative 1, 0, 3. My range is all my y values, so I have negative 1, 3, negative 2, and 0. Negative 1, 3, negative 2, 0. So my x values and my y values. Number 7. Evaluate the function below for the output when x equals 0 and x equals 4. Okay, so if x equals 0, so I'm going to make my little table. If x equals 0 or x equals 4. So when I plug in a 0 here, I get 3 times 0 plus 1. That's 0 plus 1 is 1. And then if I plug in 4, so I have 3 times 4 plus 1, 12 plus 1, 13. So I have 0, 1, 4, 13. So let's do it for this one. I have my x and my y. I have 0 and 4. So I have negative 2 times 0 minus 4. So I have 0 and negative 4. Negative 2 times 0 is 0. So now I have negative 2 times 4. Negative 2 times 4 minus 4. Negative 8 minus 4. Negative 12. Uh-oh, I haven't been putting boxes around my answers. Please make sure you put boxes around your answers. Alright, find the value of x so that f of x equals 3. So if you remember, f of x is our y value, right? F of x is our y value. So on this line, where does y equal 3? So right there. So our y value is 3, and our x value for this is 2. So where does f of x equal 3? Well, f of x equals 3 at 2, 3. Alright. F of x equals x minus 3. Find x so that f of x equals 5. Well, we know that this is f of x, f of x. So we just plug in the 5 for the f of x. So we have 5 equals x minus 3. So we have x equals 8. Find the x and y intercepts of the graph of each linear equation. Hint, where x equals 0 and y equals 0. That's a great hint. So if you have this, so make y 0. So I have 2x plus 3 times 0 is 0. Divide by 2, I have x equals 3. Then I do it again, but this time my x value is 0. So I have 2 times 0 plus 3y equals 6. So it's 3y equals 6. 2 times 0 is 0. So y equals 2. So there's my x and y intercepts of this. Now for number 12, x and y intercepts. So let's start off with the y. So I have negative 3x plus 5 times 0 equals negative 30. 5 times 0 is 0. Negative 3x equals negative 30. Divided by negative 3. X equals 10. We'll do the same thing. Negative 3 times 0 plus 5y equals negative 30. So 3 times 0 is 0. So I have 5y equals negative 30. Divide by 5. Divide by 5. Y equals negative 6. So there's my 2. My x-intercept is 10, 0. My y-intercept is 0, negative 6. The points represented by the table lie on a line. Find the slope of the line. Well, we know that slope equals the change in y. Change in y over the change in x. Look, the x is at the top, the y is at the bottom. Make sure you switch them. Alright, the change here, I have plus 2 plus 2 plus 2. So the change in x is consistent. The change in x is a positive 2. Change in y is minus 3, minus 3, minus 3. So my slope equals negative 3 over 2. Alright, let's move on. Number 14. X minus 3y equals 6. So we need to graph the linear equation. So, hint, solve for y or use x and y intercepts. So, depending on which way you did, I'll do the x and y intercepts first. So, if I have my x equals 0, I have negative 3y equals 6, divided by negative 3, and I have y equals negative 2. And if my x equals 0, oh wait, yeah, oops, that's my x equals 0. So if my y equals 0, then I get x minus 3 times 0 equals 6. 3 times 0 is 0, x equals 6. So there's 1. So I have my 0, negative 2. And then I have 6, 0. So there's 2. Now that's solving it using x and y intercepts. Another hint is to solve for y. So if I take this, x minus 3y equals 6. Subtract x from both sides, I get negative 3y equals negative x plus 6. Because I can't add those together, so I have to keep them separate. Now I divide by negative 3, negative 3, negative 3. So I get y equals negative divided by negative is a positive. So I get 1/3 x. So that didn't make sense. So x over 3 is the same, because this is 1x, right? It's the same as 1/3 x. So I get 1/3 x plus 6. Oops, oh gosh. Divided by 6 divided by negative 3 is negative 2. Good heavens, negative 2. So I have my slope equals 1/3, my y-intercept equals negative 2. So I go to negative 2, then I have slope of 1/3, 1, 1, 2, 3, 1, 1, 2, 3. So either way you solve it, you get the same line. Looks like that. Alright. Wow, that's convenient, right? This is already written in slope-intercept form, so my slope is negative 2/3. My y-intercept is 1. So I go to my y-intercept, which is 1. And then I do negative 2, positive 3. Negative 2 is down, 1, 2, 1, 2, 3. I could also go positive 2, negative 3, 1, 2, 1, 2, 3. There's my line. Boom. Alright. Got it? Ooh, number 16. The function c equals 150 plus 0.25 m represents the cost in dollars of renting a car after driving m miles. Identify the independent and dependent variables. Well, independent is our x value. Is m, which is miles. Our dependent, which is the one that changes depending on dependent, maybe that's right, is the cost. What would the cost be to rent the car to drive 100 miles? So I plug in 100 for m. So I have my total cost is going to be 150 plus 0.25 times 100 because of 100 miles. 150. 0.25 times 100 is 25. So I get $75. All right, extra credit for those of you going above and beyond. Your class is raising money by selling boxes of candy. The total cost of candy is $120. Excuse me. And you charge $6 per box. The class's profit is given by the function p of x equals 6x minus 120, where x is the number of boxes of candy sold. How does the equation for p change in each of these situations? You increase your supply by spending an additional $150 on candy. Write the new equation. Well, our profit is, if we haven't changed the cost of the candy, it's still $6 a box. But our profit doesn't start until we get to 120 plus 150. So we have to add 150 into this equation. Because if you remember, our original equation is p of x equals 6x minus 120. If we do an additional 150, we have to add it to this. So we get 270. 120 plus 150 is 270. So that's how our equation would change. Now what happens if we increase the amount we charged per box of candy to $8? Well, now we go back to our original equation, and here's the price per box. So our profit is going to be $8 times every box minus 120. There you have the test corrections for Chapter 3 tests.